So today we're going to do lesson 5, which is two-way frequency tables. We learned a little bit about frequency tables last year, and even in 6th grade you were supposed to learn about frequency tables slightly. So today we're going to be taking them to the next level. If we're able to do this lesson, like I said yesterday, just try to at least give it a watch and follow along so that you at least have the information. So far we've worked with quantitative data for a single variable, which means numbers, weights, measurements. Like we did the weight of the baby chicks, we did grades on a test, etc. But we can also work with something that's called categorical data, which we did spend a little time on in 7th grade, deciding whether something was a category or whether it was a numerical measurement. So a categorical data is data that shows how many things surveyed fall into a given category. So things that can't necessarily be measured by numbers. So if we were in class, we would do this together. We would be surveying a category of what color eyes we all have, right? So brown eyes, blue eyes, green eyes, other. So all those surveys of data that contain only one category are interesting. Statisticians are often interested in how responses to two categories relate to another. So, for example, we sometimes want to know how a person's gender, which is one category in itself, affects what profession that they prefer when they grow up. So, for example, something very common is that teachers are more often women than men are. So those are two categories that are related, and this is sometimes more popular research than the numerical data because people are very interested in how categories affect each other. We might also want to know if a person's hair color, which is one category, has any relationship to their eye color, which is a second category. So what we can do to look at those relationships is create a two-way frequency table. So we're going to learn how to do that right now. So to show you what a frequency table looks like, we have this example here, exercise 2. A class of 20 students recorded their hair color and their eye color, and it's shown in this two-way frequency table. So the way it works is you have one category on the top and one on the side, and then you total it both ways. So you have a total of this category, and then you have a total of this category. So for example, all the people who had black hair are in this column. So there's a total of 9 people with black hair. People with blue eyes are on this row, and the total is 8. So there's 8 people with blue eyes. The two-way frequency table shows us both at the same time. So people who have black hair and blue eyes, there's 3. Okay? People with black hair and brown eyes, 5. Black hair, green eyes, 1. Okay? And so on. So let me just erase all these pencil markings I just drew. It's going to bother me. So that's how we look at a frequency table, two-way frequency table. So first question, how many students had blonde hair and blue eyes? So you go to the blonde hair and blue eyes section, and we can see 4 kids had blonde hair and blue eyes. How many students had red hair altogether? So go to the red column and go down to the total, which is 4. 4 students had red hair. Okay? Now, here's where things get interesting. We're going to talk about what's called joint relative frequencies and marginal relative frequencies for the data above. So what the heck does that mean? So what it means is we're going to be putting each of these numbers out of the total number of kids that were surveyed, and then we're going to make that into a percent. So here's how it works. If there were 3 kids who had black hair and blue eyes, that's 3 kids out of the total of 20. Okay? So you can just use your calculator for that. You're going to do 3 divided by 20. Oh, it would help if my calculator was on. 3 divided by 20, which is 0.15, which is 15%. And remember, if you're still not good with percents, you just take this and multiply it by 100. Okay? Right? So I'm going to have you guys fill out the table. I'll show you how to do the totals as well. It's nothing different. For example, the total is 9 here. So kids who have black hair, it's 9 out of 20, which will give you 0.45 or 45%, okay? So you can please pause, fill out the rest of this table and then unpause to make sure you did it correctly. Each value, you're putting it out of the total number of kids and then calculating that as a percent. Okay, so pause and give it a shot and then unpause. Okay guys, so here are the totals that you should get. So for black hair, what basically each one of these, what you should notice is that each of the totals should end up adding up to 100%, and then in the middle, all of these should add up to 100% as well. So what this is telling me is that 15% of the class has black hair and blue eyes, 20% has blonde hair and blue eyes, 5% has red hair and blue eyes, no one has red hair and brown eyes, 10% has blonde hair and brown eyes, 25% has brown eyes and black hair. So what we're talking about here is, it's called relative frequencies for a reason. So it's relative to what it is you're looking at, okay? So a total 45% of kids have black hair in the class. A total of 35% of kids have blonde hair in the class. And then a total of 20% of kids have red hair in the class, okay? So the totals are showing for the whole class, then these on the inside are relative to what it is we're looking at. So it depends on which way you're looking at it. So this way we're looking at 15% of kids who have black hair have blue eyes. Or you can think of it as 15% of kids who have blue eyes have black hair, okay? So that's why it's called relative frequencies. So what we want to talk about is understanding the associations or trends within the data set, and actually seeing if there is a connection between the two categories that you're looking at. So we're going to talk about conditional relative frequencies, and these can get a little tricky, so make sure you pay very, very close attention. So to find the conditional relative frequency, what you have to do is you have to ask yourself how many people have this certain category if they have another. So what you have to do is relate the one you're looking for to the one that they're asking you about. So the only way to really show this is to do the example. So we want to know, what's the conditional relative frequency of having green eyes if you have red hair? So what you want to do is you want to do what you're looking for over the if. Okay, I know it sounds silly, but it's the easiest way to do it. So I'm looking for, if you have green eyes, what the probability is of you having green eyes if you already have red hair. So what we want to do is if you have red hair, you want to look at how many people have red hair. So how many people have red hair in total? It's 4. And now you want to see, out of people with red hair, how many of those people have green eyes? And that would be your 3. So what you're going to do is you're going to say 3 out of 4, which hopefully you all know is 0.75 or 75%. So 75% of people, if they have green eyes, if they have red hair, will have green eyes. Interesting, right? So let's take a look at this one. What is the conditional relative frequency of having green eyes if you have black hair? So we want to know how many people have green eyes if they have black hair. So first we want to see how many people have black hair, which is 9, so that goes in the denominator. And out of those 9 people, how many of those have green eyes? 1. So that's 1 out of 9. If you put that in your calculator, you're going to get 11 hundredths, which is 11%. So there is an 11% chance that if you have black hair, you're going to have green eyes. Okay? So now, does it appear that having green eyes has a dependency or at least an association with having red hair? And then explain. So in this case, does there appear to be an association between having red hair and having green eyes? So what we saw was a 75% chance, right? So there's definitely an association, perhaps even a dependency. The interesting thing is that if you look at how many people have green eyes from the percentage of people that have green eyes, 25% of people have green eyes. But if you have red hair, 75% of people with red hair have green eyes. So there's a way higher chance of having green eyes if you have red hair. So yes, it does appear. You are far more likely to have green eyes if you have red hair. Okay, and then you can even say that it's a 75% versus the 25% of regular people. Okay, huge difference. And then for part D, is it more likely that a person with black hair has blue eyes, or that a person with blonde hair has brown eyes? Okay, so we want to know if you have black hair, will you have blue eyes? Or if you have blonde hair, will you have brown eyes? So blue over black basically is what we're going to say. So if you have black hair, go to black hair. There are 9 people with black hair. Will you have blue eyes? So how many people out of those 9 black-haired people have blue eyes? There's 3. So that's 3 9ths. I should have written that over here. Black hair, blue eyes. Okay, so 3 9ths is going to give us 0.33, which is about 33%, which means there's a 33% chance in this case that if you have if you have black hair, then you have blue eyes. And now let's check it out. If you have blonde hair, what's the is it more likely for you to have brown eyes? So let's check out the blonde hair. There are 7 people with blonde hair, so that's going to be in your denominator. And how many of those people have brown eyes? And that's 2. So 2 people out of 7. That gives us a 29% chance. Okay? So it's more likely that a person with black hair has blue eyes. Okay? And finally, let's finish up with exercise 4. We have a survey here of 52 graduating seniors. It was conducted to determine if there was a connection between the gender of the student and whether or not they were going to college. So based on this data, what's more likely? That someone going to college is female, or that someone who is female is going to college? They might seem like the same thing, but they are quite different. Okay, so here's how we have to do this. Someone going to college is a female, right? So what we want to know is, if someone is going to college, are they female? Okay, so the first one, someone going to college. Let's see how many people are going to college. The total is 29. Okay, and how many of those people are female? 13. 13 of them are female. So when you put that into your calculator, you're going to find 0.45, which is 45%. So someone going to college is female, is 45%. Okay, and now we're going to find if someone is female, are they going to college? So someone is female, is going to college. Okay, so that means if someone is female, are they going to college? So how many people are female? The total is 22. So this is going to be out of 22. How many of those females are going to college? 13. So when you plug that into your calculator, 13 out of 22, you're going to see that it's 0.59. So 59%. It's more likely that a female is going to college than someone who's going to college is a female. Very interesting, right? And that is why we do two-way frequency tables, and that is why we look at this type of thing. This is probably the most common type of statistics that's studied, looking at how two different categories relate to each other. What kind of relationships are there? Okay, so it's very interesting stuff, and it's good to know how to do. So I hope you guys enjoyed this a little bit. And those of you who enjoy statistics, you'll probably end up taking an AP statistics class in your senior year, or even earlier than that for some of you. And at the very least in college, you'll probably have some more statistics classes. So this stuff comes in real handy when you do that. Okay, have fun.